And I'm live. That is pretty cool. Today is 25th of January 2026, Sunday, and let's just start solving some questions, some problems, not questions. Yes, some problems on code forces. Problem set 1500 rated problems, and not just this. There were also some problems that I had to do which I haven't done. One of them being problem number 4 from the last contest. Okay, let's do that one before moving forward in this contest. Problem number this, and for which I will just look at one of the solutions. Standings. Someone, let's look at this case one's solution for C2. Shit, not the problem, but the solution. Case one, C2. This is the solution, and that is a lot of things that are happening here. Built-in CTZ. Wait, what is built-in CTZ? Built-in CTZ, C++ CTZ is a non-standard compiler intrinsic provided by GCC and client that counts the number of trailing zeros bits from the least significant bit of a given integer. For instance, C++, it is recommended the okay, it gives the number of trailing bits, zeros. K, that is something. Okay, so this goes into bits. Yes, this like yes would consider some bit logic because we want the XOR to be equal. Yeah, we are taking the XOR here. Okay, we will look at this later. Let's do some 1500 related questions, problems. Min-max sort. Let's see this one. Stopwatch. And one more thing before starting the problem. I have to change the keyboard so that modify keys for the USB keyboard, the caps lock acts as the control key, which is very cool, and it just like gets reset somehow. Competitive programming, start new vim and timer and cool. Okay, you are given a permutation p of length n. A permutation of length n is an array of, yes, you can perform the following operation any number of times, possibly 0. Following operation any number of times. Choose two different elements x and y and erase them from the permutation. Okay, this is whole. Okay, and this whole thing is one operation. Then insert the minimum of x and y into the permutation in such a way that it becomes the first element, and insert the maximum of x and y into the permutation in such a way that it becomes the last element. So take two numbers and put the smaller one at the start and put the greater one at the end. For example, in this, and we want to apply the operation to the elements 3 and 5, then we will have 3 1 4 2 5. 3 1 4 2 5. Yes. Okay, your task is to calculate the minimum number of operations required, operations described above to sort the permutation p into ascending order. So we have to look at which operations and the number of inversions. In this case 1 is at the right place, but not just that. Okay, our final choice should be 1, the smallest number in the whole array, and the is biggest number in the whole array. If this is the thing that we are beginning with, and the link of the problem is here. Hello, give the lead code contest? Nope, I haven't given, like, I don't give lead code contests. Maybe I will give the next one on the next Sunday. I've been doing DSA for the last 2 months, seriously. Before that, I used to practice occasionally. Still, I'm not able to pick up the patterns, and I don't know where I am going wrong. Any tips? I mean, 2 months is 2 months of serious practice is a like enough time to get to pick up patterns, but it depends on how many questions you are solving and how much thought you are giving to questions, to problems, and I would just say solve problems. That should be enough. That is what it took me to pick up patterns. Just solve problems. Yeah, and solve problems and look for like general patterns, general tricks which are helping you solve problems. And for easier problems, it is just like it is a built-in thing. It develops over time, instinct which helps you solve problems. Okay, the first line gives n, and then the n distinct integers. If this is our initial array, no, if this is our initial array, we want to make this 1, 2, 3, 4, 5. Then we know that our last operation would be choosing 1 and 5, which means these three things must be in order. These two are already in order. We want to put 4 at like later point, for which we will choose 4. 4 will go there to their right, and for the smaller number we can choose 1, and then we will choose 1 and 5, and it will work out. Yes, so answer for this one would be 2. 15423, 15423. Answer is 2 for this one. This one is already sorted. For this one, answer is 1 because you can just choose 1 and 4. 2 and 3 are already in place, relatively speaking. And here 1 and 6, 1 and 6 will be our final choice, and except 1 and 6 we have to see 2, 4, 3, 5. They should, okay. This our final choice would be 1 and 6. Okay, before final we can have 1 and 6 anywhere, does not matter. We just have to make sure that the remaining numbers other than 1 and 6, they are in assorted order, which they are not. So among these, 2 is the smallest and 5 is the biggest. So 2 and 5 would be our second last choices. Our last choice would be 1 and 6. Our second last choice would be 2 and 5. And then for the remaining one, 3 and 4. 3 and 4, they are also not in order, so we will choose 3 and 4, I think. Yes. And answer would be 3 because we are making 3 choices. Answer is 3, but is this a general formula? So the formula that I'm suggesting here is we look at the first element, which is always 1, and the last element n. And yep, and we can call a function recursively here. And n is at minimum 1. We will have I which goes from 1 till n by 2. 1 till n by 2. Okay, 1 till n by 2, no. We will look at the first and the last element, and those would be our final choice. And when we do make that choice, before that we must have all the numbers from the range 2 to n minus 1. They should be in an ascending order, and our goal would be to find the answer for this range. Okay, and for this range the answer would be, n 2 to n minus 1, 2 to n minus 1, and we will look at 3 to n minus 2 in this range. Answer for this range, okay, makes sense. For each function call we will have a starting point and an ending point. We will look at the starting and the ending point. If the starting point and the ending point are at their own indexes, if one is at the first and n is at the last, if one is at the first and n is at the last, then answer for this would be, call the same function f for s plus 1 and end minus 1, this thing. And if this number is greater than 1, then we will add 1 to this. But if this number is 0, then answer would be, we will add just 0, which is just 0. Okay, that seems like good enough. And our base case would be when base case would be when e minus s either equals to 1 or s equals e, s equals e. If s equals e, then answer is 0 because there is only one number in our range. But if e and s, this is like this, we will also have an array a r r, where if we give I, then we will get the index of the ith number, or more correctly, array x would give us I, the index of the xth number. That, I think that is cool, and that should work here. Let's see. What's that? Int a size n for int I equals 0, I is smaller than n, I plus plus c. C, and we have I is the index of number c, so we'll say a c equals I is the index of c, right? And we will have a function which returns an integer, and recur would be the name, int uh, l and int r, and it will also take in our vector array a. And if r equals l, then return 0, and if r minus l If r minus l equals 1 exactly, then answer would be return index of r should be to the right of l. What should be a r smaller than a l. So if a r is smaller than a l, then we will return true, which means we do need some operation here, otherwise we don't. And in the else case, in the else case, res equals, call this function again for l plus 1 and r minus 1 given a, and return depending on res. If res plus, if res is some non-negative number, if res is 1, then we will add 1, otherwise add 0. Or we can just here say res greater than 0. If res is greater than 0, then add 1 to res, otherwise don't. And then I think here int response should be recursive call to L1 and N, R is N and A, cout res, and does not work. Okay, 3, at least 3 works, but here we get 0. Why do we get 0 here? We get 0 here for this. Let's also print our vector A 0 1 2 3 1 2 3 4. Okay, cool. For this, for in this array, our A array turns out to be 0 0 0, and 2 is at location 3, 0 1 2 3, and 3 is at location 4. This is at location 2, and 5 at location 1. Okay, and for we first call this function for 1 and 5, and we given a. So f1 function call, answer for this is second function call f2. This depends on f2, where we have given here 2 and 4 and our array a, and for this answer depends on third function call 3 and 3 and a. So 3 is 3 for when this is same, we just give 0. We just give 0, and yes, this also depends on one more thing. Yes, here this, and here not just this. Yes, there are a few other cases. If a r smaller than al, if okay, if a r is smaller than al, this or res is greater than 0, or res, in that case res plus plus, and or not cout, but return res, and I think now we should be good, hopefully. Okay, wrong answer. For this one we are saying 0, but the actual answer is 1 for the third test case, which is this. Why are we saying 0? because we are looking at order of 1 and 4. 1 and 4 are at their correct places, which is cool. Okay, and one more thing, and one more thing. Yes, shit. We also have to check here one more condition, or location for L. Ideally, if you are looking for the Lth thing, yep, or AR is not equal to R minus 1, or AL is not equal to L minus 1. Cool. And now I think this will work for all the test cases, hopefully. Our workspace, wait, before submitting, I would like to rewrite the whole solution. Yes. Boilerplate, go back above n, taken n, and then vector int a size n plus 1, and with n also declare here 3, and for int I equals 0, I is smaller than n I plus plus, or here instead of 1, here we can say I goes from 1 to n, taken c and a, c equals I, and we have a function which returns a integer, and we will call it a recur. It takes in a left number and a right number and a vector of integer reference a, and if we have L equals R, then just return 0, but else if we don't have to check else, if uh, R minus L equals 1, then return a r minus a r smaller than a l. If a, if you are just looking at two numbers, then we have to consider two things. First of all, these two numbers should be in correct order, relatively speaking, and also they should be at the correct place. Yes, they should be in the middle, right? They should be in the middle. No, I think no, no, no. I think that would not work. That relatively should be in the right order and also in the right place. For place, do we have to check for place? Do we have to check for place? No, for when we only have two numbers, I don't think we should check for place. Okay, int res, otherwise int res equals recur for L minus 1 and R plus 1, and also given A. And now if either A R either these two numbers A R is smaller than A L, either these two numbers are not in order, or they are in order but res is positive, which brings them out of order no matter what, or res might be 0 but these numbers are initially also not in order, which would be like checking for A R is not equal to R or A L is not equal to L. Whatever the case, increase risk, return risk. Response is recur 1 comma n comma a. See out. Segmentation fault is crazy. If L equals R, then this. Yes. Okay. L plus 1 and R minus 1. Cool. And I think this will fail. This will just fail. Let's see. I feel like this will fail on test case 2 or something. Yeah, it seems like something is not being checked for here. Yeah, test case 2, this fails. Yep, this fails, and the camera is blurred. Shit. Let me fix it. Thank you for pointing that out. Wait, shit. I think, yeah, this happens sometimes. And for the rest of this stream, I will stream without the camera. Yep, you won't be able to know. It is me streaming on who. So answer 2 we are getting wrong for answer number 2. Okay, there is something we are not accounting for, and our initial hypothesis is that whatever the size of the for the whole array, if this is our array, then we are saying what is the answer, minimum number of operations for when we are excluding the last elements, when we are excluding the last elements, or when we are only looking at the first and the last element, first being n, first being 1 and last being n. If these two are out of order, then shit, we might be able to fix them by choosing one with some other number. Yeah, shit. I think here we are outputting a higher number than the actual answer. Let's see. Expected one, found two. Yes, we are outputting a higher number. We are returning a higher number. Okay. So, yep. This thing, our initial assumption is wrong. That is, if we have two numbers out of order, then by choosing those numbers as a pair is the only way to fix them. That is not the way to do things. Yep, that is not the way to do things. Mhm. Nope, nope. And at the end, we want the whole thing to be in order. At the end, we want the whole thing to be in order. And if you have this, something like this, if we have something like this, at the end, we want 1, 2, not 6, 1, 2, 3, 4, 5, 6. We want at the end something like this. So 1 and 6 would be our final choices, and before them we will choose 2 and 5, and before that we will choose 3 and 4. So wait, shit, we know that the smallest answer is 0. So lower limit for the answer is 0 and the higher limit for the answer physically cannot be greater by n by 2. So we can say that n is never the answer. Maybe we can apply binary search. Given a number, let's say x in this range 0 to n, can we figure out whether we can convert this whole thing into a ascending array using x number of operations? Can we figure that out? What we do know is we have to begin from the middle. Yep, we have to begin from the middle. Let's say x equals 4. Can we convert this thing into correct into ascending array using 4 operations? Here we know that n is 6. N is 6. So we want first of all 3 and 4 in the middle. We will look at, wait, no, don't want 3 and 4 in the middle. We will just look at their order. No. Choosing 3 and 4 directly is not very cool. Yes. Yep, choosing 3 and 4 directly is not very cool. Yep. X we have maybe binary search. Maybe binary search. We do know the lower limit and we do know the upper limit. Maybe there is a function we can use. We can write for determining if a current given number is right or not. Choose X and Y. Choose X and Y. Choose X and Y. Shit. Yep. Yes. Choose X and Y so that this works. Mm. Wait, what even are X and Y? Um, binary search, binary search for a given number to be the correct number of solutions, to be a valid answer, to be like to be a number of operations which we can use to convert this given number array into a valid array. Can we figure it out? L equals -1 is never the answer because -1 does not make sense. So our answer would always be in the range. L is never the answer. R is always a valid answer. Yes, so we will just keep reducing this range and our final answer will be L plus 1 because L is never the answer. So L plus 1 would be the answer when R minus L equals 1. R minus L equals 1 when we have only one number in our range, and that number would be L plus 1. But that all comes after we have figured out a function we can use for checking if a given number of operations can be used to convert this array into an ascending array. To convert this array into an ascending array. To convert this array into an ascending array. How do we do that? Uh, we have these numbers. We have to convert them into an ascending array using some m amount of operations. What we have is 5 2 4 5 2 4 1 3 6. Let's say it does not matter what the actual number is. If we have some number m equals, let's say, 3, we have to determine whether this many operations are enough to convert this into an ascending array. Okay, we know that 3 and 4 are out of order. Yep, and they should be in order. You also see that 1 and 2 are out of order, and 5 and 6 are out of order. 1 and 6, they should be in order, and 2 and 2 and 5 should be in order, which they are not, and 3 and 4 should be in order, which they are also not. So shit, I think we can just look at whether 3 and 4 are in order or not order. 3 and 4 are not in order, so we must use one operation here to fix their order. Yes, to fix their order, and we would have one operation there, and then one operation on 5 and 2, and then one operation on 1 and 6. Okay, let's use this. Let's use this. After taking in a, we have to say int L, which is never the answer. L is -1, and R is N. R is always the answer. While R minus L is greater than 1, while range is something cool, int N, M equals L plus R minus L divided by 2. This number divided by 2, and we have to check if this range is okay, or if this is okay or not. We'll have a function bool which takes in int M and vector int reference A. Okay, using number M. Okay, int cnt equals 0, and we will begin with int for int I. Int I equals 0, I is smaller than, or 2 into I is smaller than n, I plus plus. What is n? That is a nice question. A dot size, that is n, and if we see that a, I, and the number on the other side, this number or 1 makes more sense here, and equal to makes more sense here. So if n equals 3, we will go 1 and 2. No, we will just go I equals 1. And I is the number on the left, and the number on the right would be, number on the left has a higher index than number on the right. Number on the right is n plus 1 minus 1. If that is true, then count increases, and at the end return count smaller than equal to n. This is the correct right number. Yes, when n equals 3 and I equals 1, this would give us 3 plus 1, 4, minus 1, 3, which is correct. Okay, cool. We have this. So if okay, what number is okay? If m with a is okay, then we'll say L R equals m. Else we will say L equals m if this number is not okay. And at the end, our answer would be n plus 1. And hopefully this works. Or this might just give us out of bound error. L equals minus 1. 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 And shit. Hey, yep, these are very random, but I am stuck at 900 level questions. The mathematical solutions it just doesn't hit while solving. I thought I should ask you maybe. Yes, you can. Okay, so for like lower rating problems, the only thing, the best thing, or the only thing you can do is just solve questions, just solve problems, and that is the best thing because most of the things are like ad hoc, random things. Most of the things required at a lower rating are random observations, instincts, which will only develop after solving a bunch of problems. And yep, there is no other way to get there. Just keep solving random questions. Yeah, that is the only thing you can do at that rating. Like I also get stuck. Like people always get stuck at lower rated problems. That just happens. Okay, and hmm, here we are getting out of bound, which does not make sense. Okay, why are we getting out of bound because of this? N equals a dot size. Yes, we are getting out of bound because of this. N equals a dot size minus 1 or till 1, but here. Yes, now, okay, shit. I was hoping now it would work, but okay, it is not. And now, yes, now it like at least we are not getting out of bounds, which is cool. Here we are getting 1, here we are getting 0, here we are getting 3. Okay, okay, let's say whenever we call the okay function, we'll say for m, what we got from the okay function was this. Compile and run. We just have one test case, let's say, and we'll use this one. Okay, so we are saying for 2, we do have a solution. Oh, okay, well, like for if you use 2, then we do have an answer. That is good. And for 1 also, we can turn this thing into the right, in the right order, which does not make sense. Yes, it does not make sense. Yes, it does not make sense because here we the opposite of 1 would be 5 from the right, and then for 2 we have 3. Yes, and then we have 4. Wait, no, for 2 we have 4 which are in outer order, so if we were to swap these two, they will be in order, but they will not be in order in like in the way that this should be. That is 1 should be here, 2 should be here, 3, 4, and so on. Okay, so this is like messed up. Mhm. Here the answer is 2. Answer is 2. We can use 2 and 4 right now, and then 1 and 5, and that would give us the correct answer, which is correct. Yes, 2 and 4, and then 1 and 5. When we do use 2 and 4, okay, for n equals 5. Let's say we have 1, 2, 3, 4, 5 here. Relatively speaking, 1 and 5 are in the correct order. Okay, shit, 2 and 3 are not in the correct order. 2 and 3 are not in the correct order. But we do not care about 2 and 3. We are only looking at the numbers on the opposite sides, which would be 1 and 5, and then 2 and 4. So 1 and 5, they are in the right order, and then 2 and 4, they are also in the right order, and 3 is in the middle, does not matter where it goes. Yep, 3 is in the middle and it does not matter where it goes. Our final answer would be, first of all, we have to solve and put out of order things in order. Out of order things in order, and then, and also, when everything, or like all of these numbers at the opposite ends, they are relatively in the correct order, then we want the whole array to be in ascending order, which in this case we want 3 to go here, for which 1 and 5, 1 and 5, we can use 2 and 4, and we will get 1, 2, 4, 5, 3. Then we can use 1 and 5, 1 and 5, and we'll get 1, 2, shit, 4 is here, 4 is here. So initially we can choose 2 and 4. Yes, we can choose initially 2 and 4, and we will get 2, 1, 3, 5. Wait, where is 4? And then 4, and then we can choose 1 and 5, and we will get 1, 2, 3, 4, 5, which is in the correct order. Hmm. Yep, that is in the correct order. That is in the correct order. That is in the correct order. Uh, okay, if n is odd, that is one case. And if n is even, that would be another case. Mm, shit. N is odd or n is even, and there are like other distinctions. Yes, no, camera is not working. Let me check again. Yep, camera is not working. It is blur. Yeah, faceless YouTuber. Mm, N N okay. And yep, this is the problem that we are trying to solve. And shit, this is the second time me sending this the link. But yeah, this is the problem. N equals 0, n could be odd or n could be even, and all of the numbers in the array. And yes, there is a assumption, or you could say axiom, that I have taken, um, by because of which I'm only looking at numbers which are at opposite ends in the ascended array. If, like, n equals 7, then we want the final array to be like this: 3, 4, 5, 6, 7. And due to some reason, I'm just looking at these numbers which are at the opposite ends of this final array. Okay, for when n is odd, then we will have a single number in the middle. But when n is even, let's say n was 6, then we will have two numbers in the middle. Okay, genius. No shit. Yes, that is what we will have. But okay, there is also this point that if we begin from looking at the smallest pair which is out of order, let's say this is the innermost pair, and yes, let's say this is the innermost pair, and we will begin by looking at the innermost pair. If either this innermost pair is out of order, we are talking about when n is some odd some even number, let's say 8. When n is 8, 5, 6, 7, 8, when n is 8, some even number, then this is the innermost pair. Now if this innermost pair is either out of order, that is we have 5 somewhere to the left and 4 somewhere to the right. If this is out of order, then we have to fix this. That will require one operation. Or if 4 is not at this particular index where it should be, that also is a cause for concern. In both the cases, we will do one operation. And yes, we will do one operation. And also, if we are doing one operation for a smaller pair like this, then we must do operations for all the rest of the numbers, uh, even though they might be in correct order, because if which if let's say this was 5 and 4, if these two numbers were out of order, then after choosing these two numbers, we will have 4 here and 5 at the end, which disrupts the places for all of these numbers which are even right now in the correct order. So after that, we would have to choose 3 and 6, and then 2 and 7, and then 1 and 8. So we will begin from the innermost pair, and yes, we will begin from the innermost pair. First of all, we will look at their order. If they are out of order, then we will like do one operation here and one operation for the all of the numbers on the left, like all of the remaining number of pairs. And also if they are not in the correct position, then also we will do one operation. And when n is odd, let's look at this. For this, n is odd, so innermost number is 3, which is odd, right? And since we cannot choose a single number, I think we can just ignore this, in which case we will move on to the second pair which is out of order, which is this 4 2. And yes, this is out of order, so we'll do one operation here and one operation on the remaining number, which is this. So in total, two operations, which and so we get 2 here. 2 n is odd, so we do not look at this pair, we look at this. This is in order and at their correct places, so 0. And then here the innermost pair is 2 and 3. They are in order, but shade. These two, 2 and 3, they are in order, but they are in order, but they are not at their correct places. Yes. but we can so we do not have to choose them as the first pair because they are already at the place where they would be if we were choosing them as the first, as the like yes, as the like first pair. So we will just do one operation on the remaining pair, which is this. Answer therefore is 1. And for this one, we look at the innermost pair, which is 3 4 out of order. We do one operation there and one operation for all of the remaining pairs. So answer is 3 at the end. And hopefully this is a working theory. Let's see. Int n, and for int I equals 1 I smaller than equal to n I plus plus n plus 1 c in. And here we have that the number c is at index I. We will store their indexes. So a c equals I. Okay. We will begin from the innermost pair. Innermost pair would be int I would begin from n by 2 till I greater than 0, I minus minus. Right, if I is at one end, then the number at the other end would be n plus 1 minus I. Right, we have to check their order. So if, and also n res equals 0 initially. If here we have, if these two are out of order, then we must do an operation which would be left number is I, right number is 1 minus I. If right number has an index that is smaller than the index of the left number, then we will do an operation. Res, yes, then we will do an operation. Yeah, let first of all just consider that. Then we will do one operation, in which case answer would become res equals I. Yep, res would become equal to I. Yes, res would become equal to I. Else, if these two are in correct order but they are not at their correct places, and correct place for I should be, if AI is not equal to, the correct place for index for I should be I given. If this is not true and a n plus 1 minus I is not equal to n plus 1 minus I, in that case we have to check if we again say that equals I, and also we will like break after this less equals I, but if AI equals 1 and a n plus 1 minus I equals n, then rest minus c out rest and test. Okay, this does work here. Let's see if this is actually valid or not. And this is too much time spent on a single question, 56 minutes. Okay, okay. Running on test 1, still running on that hill. Okay, shit. Okay, wrong answer, wrong answer, wrong answer. And shit. Wrong answer. My prediction is that we are giving a higher value than the correct answer for some test case. Found 0, expected 1. Okay, that clearly does not make sense. Let's look at where it went wrong. 1, 2, 3, 4, 5. Here. Wait, here answers should be. Okay, shit. This gave wrong answer because of this condition. Okay, shit. Wait, what? The actual answer should be choosing the pair 1 and 3. Yes. Choosing the pair 1 and 3 should be the actual answer. The yeah, like correct answer. The problematic part here is that we are ignoring this number here. Yep. Yep. Uh, yes. This is an edge case. This is an edge case. 1 3 2 1 3 2 1 3 2. I here is 1. These are at the ends for which we are checking here. If these two are at the ends, we'll do res minus 1. Res became equal to 1 because of this, because I is equal to 1. But here we have to choose 1 and 3. 3 is not at the right place. 3 is not at the right place. Shit. If this was even, then this would have worked. Uh, yes, here this would have worked. For this, answer is, wait, what is the answer for this? 1 2. Innermost pair is 2 and 3. 2 and 3 are out of order. Okay, shit. Answer for this one would be 2. We'll do one operation for this and then one operation for this. Answer for this is 2. 2 and 3. No problem here. Answer for this also, and this is also 2. Yes. We can also look at this in a way that choosing 1 always as the first element. Nah, shit. Does not make sense. Okay, we have to fix our solution for this. 1 3 2 1 3 2 1 3 2. How do we generalize this? Here 1 3 2. This is odd. That is causing problem. We begin from the innermost pair and we are not going to the middle element if that element. Okay, we are not going to the middle element. We are not going to the middle element. Here first we are checking the order, and for the middle element, if n is odd, then order does not matter because it is a single number, right? Order does not matter. Hmm. Yep, order does not matter. Wait, shit, in this case middle element is 2. Um, in this one, shit, yes, middle element is 2. We are checking for 1 and 3. Yes, middle element is 2, which is not at its correct place. Yes, 2 is not at its correct place. Mm, okay, let's add a condition to check for this also. If n is odd, then if n is odd, then a index of n plus 1 divided by 2. This thing is not equal to, this should be equal to n plus 1 divided by 2. If that is not true, then rest would be, then rest response would be n by 2. Okay, correct answer here, and hopefully this works here also. Hopefully, hopefully, yes. Okay, it is taking time to submit. Okay, wrong answer. Shit, okay, we are moving on. This is not working. Wrong answer. Let's add this question to review. Yep, and yep, this was educational round. So educational rounds are cool. Educational rounds are cool. Min max sort. Min max sort. Yep, min max sort. Educational round. Cool. And yes, I would say that for today's stream, this is going to be it, because I'm running a experiment where I do not sleep. And yes, it has been more than 24 hours that I haven't slept, and I want to continue this. Yep. So yep, this would be the end of today's stream, unfortunately, and I will tell you the result of the experiments. Let's see. I aim to not sleep for 48 hours at least, and I will see how it goes. Rookie numbers pretty soon. Shit. Do you also do these kinds of experiments, Archit Mishra? Like when you do not sleep. Right now, at the nights, I am watching Stranger Things. I can tell you the results. Okay, what is your maximum? What is your maximum time that you haven't slept for? 3.5 days. Shit, that is higher than my maximum. That is higher. That is like literally higher. My higher is less than 48 hours. Slept on the night of the 4th. Shit. 3.5 hours. 3.5 days. That is quite a long time. So you didn't sleep for 3 nights. Okay, that is, yeah, that is crazy. But I couldn't study for about a week. I mean, that is fine. That is like fine. These experiments are cool. You can cover a lot of like movies and series in this time. Was completing lectures and doing questions back to back for all that time. Shit, okay. I would not be able to do that. Like, yes, I would not be able to do that. Like on low sleep, I won't be able to do problems and in lectures. No. Uh, yes, but I'm going to do it. I'm going to do it. I will not sleep, and let's see how far I can take it. And yep, for today, this would be it. Like I cannot even stream for long, because then I was pretty fucked up for about 5 to 6 days. That's fine. Like, yeah, you can just like these things are cool. They look cool. And yep, this would be it for today's stream. We didn't even solve one question, which is sad, but fine. It is fine. Yep. Okay, thank you. Hope you break my record. Well, with breaking, yes, I will. Maybe that 3.5 is a very long time, 3.5 days, but I will try. I will try. And yep, thank you for being here. Bye.